Hey class, this is Mr. Roberts at Shasta High School. We're going to be looking at questions 45 through I think 51. This is in chapter 9. Match each graph below with the correct inequality. So as you can see, I've got 4 inequalities and 4 corresponding graphs. A couple things to think about are boundary conditions and what are the boundary lines, and then is the boundary included or not included. So when I look at an inequality like y is strictly greater than the opposite of x plus 2, I know that this boundary line has to be dashed because it is not including that line. So we're looking for a dash boundary there. This one has a slope of -1, so we should expect to see go down 1 over to the right one, down 1 over 1, and a y-intercept at 2. And also it says that the y values are greater than the boundary. So if I was to look at this, I would need this isn't going to work because this is a solid boundary. I need a dash one. This one does have a y-intercept at 2, and it has a slope of, what is this slope? Down 1 over 1, down 1 over 1. So it has a slope of -1. And my y values, or they're shaded, are above the line. So I believe that the answer for 3, I could say 3, the inequality that goes with it is the inequality y is greater than the opposite of x plus 2. So this is A. So number 3 should go with A. Let's look at the next one here. For B, this says y is less than 2x minus 3. So I need a y-intercept at -3. And the only one that has that is number 1. I can see the y-intercept, and the slope is up 2 over 1. So you can see from here I'm going up 2 units and to the right 1 unit, up 2 units and to the right 1 unit. And I do have the y-intercept at -3. And also the y values that are shaded are the ones that are below it, right? Y's are less than the boundary. So this goes with B. It is y is less than 2x minus 3. I guess let's go to C. C has a y-intercept at the origin, so that's going to have to be 4. I'm just going to confirm a couple things about it. Number 4 should have a slope of up 1 over 2, a slope of a half, and it should include the boundary. So you can see it is solid, goes through the origin, up 1 over 2, up 1 over 2, so it has the correct slope. And it says y's are greater than the boundary. So this is the boundary curve, right? This is the equation of the boundary, and the y values are supposed to be larger than the boundary above it, so that's shaded above. So number 4 is C, which is y is greater than or equal to 1/2 of x. And then finally, just by elimination, it should be the case that D should be number 2. So let's take a look at it and just make sure. D has a y-intercept of 2, and I can see this has got a y-intercept of 2. Also has a slope of down 2 over 3. So if I'm here, I would go down 2 units and then to the right 3 units and then down 2 units and to the right 3 units. So it's got the correct slope. Also in D it says that it's less than or equal to, and I can see it's a solid line and it's everything shaded below that. So these are the values y that are lower than the boundary, right? Y's are less than. So this is y is less than or equal to -2/3 x and then plus the number 2. So that's question number 45. Let's go on to 46. 46 says solve each inequality, represent the solutions on a number line. So if I'm looking at this real quickly, geez, there's a lot of things here. I am going to go ahead and think about these as equations, right? So I'm thinking for the first one, 3x minus 2 is 10, therefore 3x is 12, and x would have to be 4. The significance of that is that should be my boundary location. So on a number line, on a number line, right, here's 0 and here's 1, 2, 3, and 4. This is the number 4. And it says that in the original thing it says it has to be less than, so I know that it's going to be an open boundary, but then I need to test to see if it's above 4 or below it. So I like to test the number 0, and when I plug 0 into the original inequality, this becomes 0. So this says, is -2 less than 10? Well, that's true, And since it is true that negative 2 is less than 10, that means that all the values to the right of this, but not including it, it was an open boundary, but everything to the right is part of the solution. So all the solutions live to the, I'm sorry, I said to the right, all the solutions live to the left of 4. Anything to the right of it would not satisfy that inequality. Let's try to do B. So again, I'm going to look at this as an equation, and I think I'm going to simplify it a bit as I go. So 5x minus 3x would be a 2x minus 1 is greater than or equal to 4x plus 5. I'm not paying attention to the inequality. I'm just looking at this as an equality. If I take away 4x from both sides, this is going to become a negative 2x minus 1 equals 5. Therefore, negative 2x is the number 6, and x is negative 3. So my boundary for B should live at negative 3. So let me go ahead and sketch that. You know what, I didn't write down my answer here for A, by the way. This is, I should have written x values are less than 4. So that's the solution. Let's go ahead and look at the graph of B. So I've got my number line. I know that here's 0, here's 1, 2, here's negative 3. And because this is greater than or equal to, right, or equal to, I'm going to put a solid dot. I'm going to shade this in completely. So that's part of my solutions. And then again, I'm going to test 0 into the original inequality to see if I shade to the right or to the left. When I put 0 into the left-hand side, this is just going to become the number negative 1. And then the question is it true that that is greater than or equal to? On the other side, when I put in 0, it becomes 5. So is 0 greater than or equal to 5? Well, that's false. So it does not go this way. This is false. So 0 is not part of the solution. What is a solution is 3, and everything off to the left of 3 again. So we've gone to the left both times. Again, treat the inequality as an equation. Find the boundary point, shade in the boundary. It's either solid or it's open, depending on if you had, in the case of A, it was less than, so there was an open boundary. For B, it was greater than or equal to. If it's got the or equal to it, then it's including the boundary. Let's do C right here. So in question C, again, we're treating this like an equation, so I'm going to go ahead and distribute the 2x plus 4, set it equal to 10 minus x. I'm going to add an x to both sides, so I get 3x plus 4 is 10. If I add 4 to both sides, I get that 3x is, I'm sorry, I'm not going to add 4, I'm going to subtract 4, I get 6, therefore x is 2. So it looks like my boundary condition is at x is 2, so here's 0, and then 1, and then 2. This is going to be an open boundary, again, because it doesn't have the or equal to. And I did it again, I forgot to write down my answer for B. These were the values x's are less than or equal to negative 3, so that's the answer of B. I apologize. I'll try and get C right and write it down at the first time. Okay, so for C, I know the boundary is occurring at 2, and then I'm just going to go ahead and test 0. It's my favorite value to test if I can get away with it. When I plug 0 into the original inequality, this becomes 0, and I've got 2 times 2, or 4, and on the other side is greater than 10. Well, 4 is greater than 10 is false. So that means that this test side was false. I'm not going that direction. Therefore, I have to go everything to the right of 2. So I just shaded that in with the blue there. So everything to the right of 2 going on forever is a solution. So, and now let's write that down. We are saying that x values are greater than 2. So there's the graph, and there's the solution. And then the final question, D. Again, I'll use the distributive property. I write 4x minus 12, and then plus 5 is greater than or equal. I want it to be equal negative 7. Therefore, 4x minus 7 equals negative 7. When I add 7 to both sides, that gives me that 4x is 0, and I divide by 0, I get x is, 0 divided by 4 is 0. So that means I can't use 0 as my test point this time because I am at 0. So I'm just going to test 1 point to the left or right. I guess actually testing positive 3 would be nice. So I'm going to test positive 3 in this. When I put 3 in to this inequality, this is going to become 4 times 0, right? 4 times 3 minus 3 is 0, so that's going to be 4 times 0 is 0, so I've got 5 is greater than or equal to negative 7. Well, that's true, right? 5 is greater than or equal to negative 7, so that means for this particular one, I am going to the right. I had the open boundary at 0, and it was no, not an open boundary, a closed boundary, because it was greater than or equal to. So I'll fill in the boundary, and not only does it include that point, but it includes everything to the right of that point. So my solution is 0 and everything larger than 0. Right, so and again, writing down the solution, I would say x's are greater than or equal to 0. So that is question 46. Moving on to 47. Write and solve an absolute value inequality for this situation. So the thing that's tough about this problem, the problem's super easy, right? The thing that's tough is the fact that you're asked to both write and solve an absolute value inequality. Because honestly, I could think about this and I don't need an absolute value inequality. So the purpose of this is to help you think through what that looks like, because when things get more complex, then you can rely on this understanding we're trying to build here. So it says at Acme Trucking, the average starting annual salary is $24,000, but the actual salary could differ from the average by as much as $1,575. So when you say as much as, that means it could differ by that much, but no more than that. So I know that it's going to be within that boundary. So if I was just going to think about it, here's the salary, right? $24,000. But it could be $1,575 more than that or $1,575 less than that. So I could differ by this much both directions. So in fact, let's go ahead and get the solution here. So one of them is going to be 24,000, and then I'm going to I'll add 1,575. So when I do that, I get the upper bound. So if S is my salary, right? The salary could be as high as the starting salary could be as high as $25,575. And then if I go up and I look at the subtraction problem where I take, instead of adding that, I could take that away. It could be as low as $22,425. $22,425. So what we have here is the lower bound and the upper bound. But how would I write and use an absolute value inequality to produce this answer? So a little bit of thinking on this. We talked about the fact that an absolute value shows how far something is from 0. So if I had the inequality, the absolute value of 5 is less than or equal to, I didn't mean to say that, the absolute value of x is less than or equal to 5. We're here at the 0 at the origin, but it could be, it's going inside, right? It could be as much as 5. It could be 5, but it's 5 or less, so it's pointing in towards the origin. So that inequality has the solutions. It has two solutions, right? X's are less than or equal to 5, and the other solution is x's are greater than or equal to negative 5. Okay, so but you can see here, this would be like your starting average salary would be $0. Well, we didn't have a starting average salary of $0. We had one that was way over at $24,000 or something like that. So how do I think about building an absolute value inequality that I could use to solve this problem? Now I'll know that I've done the right thing if I build one, I solve it, and I get the same solution that we already have. And you know, our thinking in classes when we looked at that is like, well, let's say that our average salary, we'll think simple here. We'll say our average salary is $3, right? And we'll say that it could vary by as much as that's a bad example. It varies by as much as $5. That'd be bad because you have a negative salary. That doesn't make sense. We'll say the average salary is $3, but it can vary by as much as $2. So it could be 2 above, 2 below. So if I think about that, I understand, oh, 3 plus 2 is 5, and then 3 minus the 3 minus 2 would be 1. So the salary range would be in between 1 and 5, right? It could be X values would have to be greater than or equal to $1, but less than or equal to 5. So how do I build that? Well, remember, the absolute value shows me how far something is from 0, not how far something is from 3. So if I want to, I can say, well, let's translate this 0.3 back to 0, right? If I shift it back to the origin, then I can talk about how far the differences are from 0. You can see right now the X value is at 3. If I want to shift it back there, I could subtract 3 from it. So this is what we did in class. I could look at the inequality X minus 3. So this is me shifting the situation back to the origin. And it's saying the difference from your origin can vary by as much as $2. So that's the example I did in orange. So as much as $2 either direction. So this is the absolute value inequality that I would use to solve for the situation. And I know the answer is going to be $1 at the minimum and $5 at the max. But let's look at that procedure again. So when we did this in class, we were saying that we've got the X minus 3 is less than or equal to $2, right? That's 1. This is less than, so it has to be, and it's also true that the X minus 3 has to be greater than or equal to the negative $2. So you can see this is me thinking of those two places, right? You're either on this side or you're on this side of it. Now if I solve both sides of this, I just add 3 to solve, right? On this side I'm going to solve and I get X is less than or equal to 5, and it has to be the case that X is greater than or equal to positive 1. So you can see there, this is the same inequality that we had above, and I can combine them, right? 1's the smallest value, and X's are in between those, and the upper bound is 5, right? So X's have to be less than 5, that's expressed here, and that's expressed here, but X's have to be greater than or equal to 1, which is what's expressed here. So you can see both parts of that are reflected in this single expression. Okay, so now how do we relate to this, to our problem here? How do we use that information, those observations, to build to write and solve an absolute value inequality? So the situation is this, right? We're over at $24,000. Now we're going to take that and we're going to shift it all the way back to the origin. So we're going to say X minus $24,000, right? So that's now just saying, hey, the most that this can differ by, the most it can differ from the origin is by 15,000, or I'm sorry, $1,575, right? 1575. It can vary by that much, but not more than that, right? Or so it's less than or equal to that 1575. And again, the procedures, you know at this point the procedure is getting pretty simple. The hard part is coming up with the equation. But you can see just by doing this, I'm shifting this. It was at positive $24,000. I'm shifting it back to the origin and talking about how far something is from 0, which is what the absolute value is used for, right? It lets us talk about how far something is, or the distance that it is from 0. So now I've shifted into that problem. So my two inequalities I get is, well, X minus $24,000, right, is less than or equal to 1575, and X minus $24,000 is, and I flip the direction, is greater than or equal to, and then I make this negative 1575. So solving this, right, it's the same thing. I'm just going to add $24,000 to both sides, and I think you can see we already got the same numbers up above, right? The numbers are on the upper end. We get $25,575, right? X's are less than or equal to that. That's the upper bound. And on the lower end, we get that when I add $24,000 to that, I get that X has to be X has to be greater than or equal to $22,425. So again, I get the exact same expression above, right? My X values, the amount of money I'm making, has an upper bounds of 25,575, and it has a lower bounds of 22,425. $2,425. So the most difficult thing about this problem is not the problem, right? The most difficult thing about the problem is the fact that we're asked to come up with an absolute value inequality that we can use to solve this problem. This is it. Shifting the $24,000 back to the origin, right, by taking X, how much you're getting paid. X is how much a random person's getting paid that's hired in this situation, and then subtracting the $24,000 and then saying, well, that distance from that value's distance from 0 is constrained by 1575. Anyways, that's certainly not the last problem that we're going to see like this, but it's one that I wanted to take some time looking at kind of closely with you. Let's move on to 48. 48 says, use the graph below to write an exponential equation in the form f of x equals a times b to the x. Okay. So if I take a look at this, there's two pieces of information I can see. I can see when x is 0, I have a y value of 0.2. That's one. The other thing that I could see is that it looks like when x grows by 1, right, when x is at 1, my y value increases by 1.4. Well, if I'm increasing, right, if I have an increase here of 1.4, that means that it's the 0.2 plus 1.4, so I've gone up to 1.6. So what is that? That's an increase of 1.4 from the 0.2. Okay, so I can now see that I've got these 2 points, right? I'm not asked to come up with the line that goes through those 2 points. I want an exponential equation in that form. So our strategy has been this, right? We're looking at this equation, y equals ab to the x power. We're looking at it twice. And I'm going to begin by taking both the x values and the y value that I have from each of these and writing 2 equations. So the first one I'm going to write is that y, which is 0.2, equals a times b raised to the 0th power. And I'm also going to write that 1.6 equals a times b to the 1st power. What's beautiful about this is probably the best case scenario, right? You can see that b to the 0 equals 1. So since this is the number 1, right, I know that a has to be 0.2. So off the bat, we got that a is 0.2. I'm not having to use the equal values method here. I can see what a is right away. And then I'm going to go ahead and take that value of a and plug it into my second equation. So my second equation becomes 1.6 is equal to a, which is 0.2 or 0.2, times b to the 1st power. Well, b to the 1st power is just b. So I'm just dividing both sides by 0.2. So I've got 1.6 divided by 0.2 is b. And when I verify that with my calculator, I get that b is equal to 8. So I have everything I need, right? If you look, I needed 2 parameters, and I have both a and b, so I can write my function in this form. So I can write f of x equals a, which was 0.2, times b, which is 8, and then raised to the x power. The 2 things I might want to check is if I put 0 into that, does it give me 0.2? And it actually does, right? 8 to the 0th power is 1 times 0.2 is 0.2. And also when I put 1 in it, does it give me 1.6? And the answer to that is also true. If 8 to the 1st power is 1 and 0.2 times 8 is 1.6. So this is precisely the exponential function that we're looking for, right? F of x equals 0.2 times 8 to the x power. All right, moving on, question number 49. It says a line has intercepts, write the equation of the line. Well, this is sweet. They gave me both x-intercepts and y-intercepts. Now, a couple ways we can do this. I am going to choose to do this like I just did the last problem, just for illustrative purposes. So I'm going to consider y equals mx and plus b, and I'm going to use the x, y, and the xy values I was given from these 2 points to write 2 equations and then solve a system. So in the first equation, I would get 0, because that's what y is, right? 0 equals m times x, x is 4 in this case, and then plus b. So that's the first equation I'm going to write. The second equation, y is -3, so I'll write -3 equals m times 0 and then plus b. So if I look at this system, it's very nice because in the second equation I can see m times 0 is 0, and that tells me immediately that -3 is my y-intercept. And I know you're saying, of course, Mr. Roberts, this point right here was the y-intercept. I got it, right? I got it. I understand. Well, but I can see this in a different way now, perhaps. Let's take that value of b now and plug it into the top equation. So if I plug that into the top equation, via substitution, it's going to become 0 is equal to m times 4 and then minus 3. So you can see I've added the b, and b was -3. Well, the thing I don't like about this is I don't have enough room. So let me solve this by adding 3 to both sides. If I add 3 to the left hand side, 0 plus 3 is 3, right? 0 plus 3 is 3. And then m times 4 minus 3 plus 3 is just going to be 4m. I'm changing the order there. So it's still 4 times m. M times 4, same thing. And then I divide both sides by 4. So m is 3/4, right? That's my slope. My slope is 3/4. So now I have both parameters, right? I have the parameters that I need to produce this line. I have the parameter of slope and I have the parameter of y-intercept. So I can write the equation y equals m, which is 3/4 times x, and then plus -3, or I could just say -3. And again, it's worth noting that if I take the 2 points I had and plug in, it does give me the correct thing. So if I think about the second point, right, when I plug the second point in, when I plug in x is 0, it does give me -3. And when I plug in x is 4 from the first point, 4 times 3/4 is 3, and 3 minus 3 is 0, so it also produces the correct value. So this is the equation of the line that goes through both of those points. All right, we're moving on now to question 50. And question 50 says, decide if the pair of triangles is congruent. If it is, create a flow chart that justifies your decision. So I'm looking at these, and I don't see them talking about parallel lines at all. But what I do see is that these two triangles do share this side, right? So I know that BC is congruent to BC by the reflexive property. And also I noticed that if I look at this angle right here, I'll mark in green, and then over here I'll mark the same one in green. And then if I look at this one, I'll mark in blue, and I'll mark this one also in blue. I can see, oh, and for clarity, I'll make the congruent line in the middle purple, right? So you can see I can go in the bottom triangle blue, purple, green, and then up in the top triangle I can go blue, purple, green. So those two triangles are congruent by angle side angle congruence. That's the congruence condition that we'll use to justify it. I could use other congruence conditions, because they did include the fact that that angle D, right, angle D, D and angle A were also congruent. So you could choose to use angle side, right? And there's a couple different ways you could do that. You could not choose to use angle, however, right? Angle is not a congruence condition. What makes this problem doable is there is the share side BC. So the proof that I'm going to write may not look exactly like the proof that you wrote, but this is what I'm going to go with. I'm going to have a pair of congruent angles. They are given congruent. Oh, you know, let me make this automatically make yeah, ink to shape. There we go. So here's a nice oval. Here's another nice oval. Here's another nice oval, and then here's a final oval. So I know that the related information, this is going to be necessary. That's going to be one of the angles. This is going to be necessary. This will be another one of the angles, and this is going to be necessary, and this will also be another one of the angles. So a flowchart proof has statements in the ovals, reasons written off to the right. So the first statement I'm going to write, and I'll write this in the middle oval here, is I'm going to say that that BC, segment BC, is congruent to segment BC. Right? That's the one that they share. And the reason for this is the reflexive property. And it's the reflexive property for congruent segments, to be clear. Okay, that's great. What do we have next? Let's talk about the angles that I highlighted in green. C and B are bad names for those angles. I could say the green angles too, but a better name for the ones that I've highlighted in green would be angle ACB, angle AC, oh, I didn't write the A, angle ACB. So angle ACB is congruent to angle, and then the green below would be, I did ACB, so I'm going to go DBC, angle DBC. So those are the ones that are highlighted with a single tick mark, right? I highlighted them in green, but those are congruent because it was given in the diagram by the tick marks, right? So I've got a pair of congruent angles, I've got a side that's connecting another pair of congruent angles, and that other pair of congruent angles are the ones that were highlighted I highlighted in blue. And the good names for those would be angle ABC, that's the top one, right? Angle ABC is congruent to angle, and then the blue one below would be DCB, angle D to C to B, DCB, and those are the ones that are highlighted in blue, and those are congruent because it's also given information. So now you can see I've got the angles, right? Here's a pair of angles, here comes a pair of sides, and here comes a pair of angles. So now I can state that the triangles are congruent. And the order does matter, right? I'll say triangle ABC, triangle ABC is congruent to, and I'm going to match that up with, there's only one way you can write it, right? Once you write ABC, ABC has to go with DCB, with triangle DCB. ABC goes with DCB, and the reason they are congruent is because of the angle side angle congruence condition. Right, that's it for 50. Let's go on to the final question, question number 51. Corey and Leah are working on homework problems that involved arithmetic sequences. Okay, that's great. Corey wrote down 2, 4, 3, 5 from one sequence, and Leah had 3, 2, 0, 3 for a different sequence. Write an equation for each of the sequences. Okay, an equation for each of the sequences. Well, again, what they're asking me to do here is to find the equation of a line that goes through 2 points, right? Because they're arithmetic. I know it's a line. And while we're doing it, let's just practice some different strategies. So instead of writing a system, I'm going to do this the way that we talked about earlier in the year. I'm just going to look at y equals mx plus b. My strategy here is I'm going to figure out the slope. So the slope for these 2 points, for the slope for any 2 points, is how much does y change divided by how much does x change. And I'll highlight the y values in blue. So here's blue is 4, and the other point blue is 5 is y. The 4 and 5 are my y values, and then I'll highlight in green the first point at x value was 2, and the second point x value was 3. So if I look at the change in the y values, right, that's the 4 and the 5. I could write 5 minus 4. I just have to make sure I follow that order. So I did 5 minus 4. That's the second point listed minus the first point listed. And then the bottom of that would be 3 minus 2. 3 minus 2. So you can see my slope. 5 minus 4 is 1. And 3 minus 2 is 1. So my slope is 1. Slope equals 1. Now that I know the slope, I'm going to use either one of my points and that slope to figure out what my y-intercept is. I'll use the first point. The first point had a y value of 4, so instead of y, I will write down that first y value, 4, and that's going to equal my slope of 1 times the x value, again from the first point that was 2, and then plus b. So you can see to solve this for b, I'm just going to take away 2 from both sides because this equals 2. 4 minus 2 is 2, so 2 is what b is. So my equation is y equals x plus 2. So that is one of the sequences. Okay. It said it was a sequence. So in a sequence, we do restrict the domain, and we kind of showed that by using this notation. So I could say t of n equals n plus 2 more. So that's an explicit definition for this sequence, right? To get the first term, I would put in n as 1, and it gives me 3. The second term, I would put in 2, and it would give me 4. The third term, I'd put in 3, and it would give me 5. So that's Corey's sequence. So now let's look at Leah's sequence. Leah's sequence has these 2 points. So let's do this a slightly different way. First of all, this is x, this is y, this is a y-intercept, right? I know that my y-intercept is 3, so I know that b is 3. Okay, I know that b is 3. So let me use a funky way to find the slope, I guess. Let me try this. Y is equal to mx plus b. I've never done this. This is weird. Let's use this point. Here's an x value and a y value. So my y value is 2. My I don't know what my slope is. X was times 3, and then my y-intercept was plus 3. So if I take away 3 from both sides, I get 1 is 3m, and if I divide both sides by 3, I get 1/3 is m. So this is looking different. So that means that this sequence is t of n is equal to, let's see, my slope was 1/3, so 1/3 times n, right, because m, the slope, is 1/3, and then plus the number 3. So a quick check for this, if I put in the number 3, this is not producing the right outputs. If x is 3, this becomes 1, and I've got the number 4. If I put in 0, I do get 3, but I am totally not getting the right values for this first point. So what the heck did I do? I see what I did. Big goof on my part. When I take away 3 from both sides, right? Minus 3. 2 minus 3 should be a -1. Oops. That means my slope is -1/3. Whoops. Which means that this should be a -1/3. Yeah, so again, can't illustrate it enough. Look at me, Mr. Roberts, you know how goofy I can be, but I'm just sitting here and I'm plugging in the x values, or in this case n. I'm plugging in n is the number 3, and I'm getting, it's not giving me the right thing. So that caused me to go back and look at what I did, and I did detect an error. So it's a beautiful thing, right? It's a beautiful thing to learn from one's mistakes. So let's check it now. If I put 3 in for n, if I want to know the third term, -1/3 times 3 is -1, and -1 plus 3 would give me 2, which is the y value I should get. And for the 0th term, if I put in 0, -1/3 times 0 is 0, so 0 plus 3 is 3. So both points are producing correct values. You know, now that I did that, let me go look at this one too and verify that this is doing the right thing. So this says to get, this is nice, right? Just to get y, you take whatever x is and add 2 to it. So you can see for the 0.24, when x is 2, I add 2 and I do get 4. For the 0.35, when x is 3, I add 2. 3 plus 2 is 5. It works. So both of these are the correct sequences. They're producing the values. You know, like, think about a sequence, right? The first term is 2, and then it goes. The second term is what? No. For this sequence, the first term is 3. When I put in a 2, I get a 4. When I put in a 3, I get a 5. When I put in a 4, I get 6. So this sequence is going up by 1 each time. It has a slope of 1. This sequence probably not as well. It's nice, but not as nice. Right. That must conclude our time. Right. I'm sure that we've spent way too much time here. So let's call this a deal. That's it. Talk to you later.